we are ready to do our next unit. Lesson 1-7, more properties of integer exponents. And it's going to be okay. We learned 4 properties Monday, and we worked with those again yesterday that have to do with exponents. And we are going to learn 2 more properties today. So we're going to have a total of 6 properties that have to do with integer exponents. All right. You just got to remember. I mean, none of them are very like super math hard. You just got to remember what the rules are and how to apply them. Here we go. Let's look at our first little intro problem. Calvin and Mike do sit-ups when they work out. They start with 64 sit-ups for the first set and do half as many each subsequent set. What representation can you use to show the relationship between the set numbers and the number of sit-ups? So, this is an interesting problem here that they've set up for us. All right. So the set number and the number of sit-ups.
32.
All right, so in the first set, how many sit-ups do they do?
64 people.
Okay, sorry, I've already botched it here. Here we go. All right, 64. First set, they do 64 sit-ups. And then in the second set, how many do they do?
32.
Okay, they do 32. And then third set, how much? 16. Fourth set, 8, and so on. We could make down a couple more, right? And let's just go ahead and do it. 5, fifth set, 4, sixth set, 2, and the seventh set, 1 sit-up. That's the one I want. I'll do that set with them. Okay, now, how did you get those numbers?
Each number in half?
Yeah, cut each number in half. That's exactly what we did. We cut each number in half. We divided by 2 each time, right? Okay, so there's a couple of ways if we were going to write an equation or we were going to use this mathematically, using some exponents or something, we could do this a couple of different ways. But one thing that I think I want to draw your attention to is that very often we think of exponents as being repeated multiplication. You agree? Repeated multiplication. So, for instance, 2 to the 6th power is 2 times 2 times 2 times 2 times 2 times 2, right? 2 multiplied 6 times. By the way, what is 2 to the 6th power?
2 to the 6th power?
2 times 2.
12.
No. 2 times 2
4.
times 2
16. Wait, no. 8.
times 2 times 2 times 2.
64.
64. 2 to the 6th power is 64. Okay? And, oops, that's just a 6. I missed the 4. There we go, 64. And so we think of it as repeated multiplication, but we also can use exponents in some other ways. We think of them as being repeated multiplication, but what's the opposite of multiplication?
Division.
Okay, so how do we use exponents to show repeated division?
2 divided by.
Ooh, 2 divided by something. Okay, so that's something to think about. How do we show repeated division using exponents? And we could do it with some fractions. Multiplying by a fraction is kind of the same as dividing, right? So instead of dividing by 2, we could think of it as multiplying by what?
Fractions or
By a half,
decimals.
right? Multiplying by a half. So if you take 64 times 1/2, what is that? 32. So how many times do I have to multiply by a half to turn 64 down into 1, right? So we can think of it that way. So we could give our half here an exponent, and we could end up chopping 64 in half a bunch of times till we got down to 1, right? So there's ways to use exponents in all sorts of scenarios. Okay, we can make numbers bigger with exponents, we can make numbers smaller with exponents, right? Okay, so that's kind of where I want you to get your mind thinking for today's lesson. What conclusion can you make about the relationship between the number of sit-ups in each set? Well, we've already talked about that. That has to do with, we cut it in half every time, right? So, so that's what I think I mean, that's kind of what I wanted to get out of that warm up, the idea of thinking about exponents maybe in some ways we haven't thought about them before. Okay, let's move on. Oh, look,
Video.
a video. And today the videos are all right. I kind of like them. There's 2 of them again, and they're going to be okay. They're not bad. No. All right.
What do the zero exponent and negative exponent properties mean? Think about this question during the lesson. Markayla is playing a card matching game with some classmates. 4 matches have been made. It is Markayla's turn, and she chooses 3 to the power of 0. She needs to know which card would complete her match. In 3 to the power of 0, which is the base? Select your answer.
Good. 3 is the base, and 0 is the exponent, right?
Really?
Okay, 3 is the base.
Begin by organizing the information in a table. We'll start with the largest number. 3 to the 4th power is equal to 81, and work down. Now you can look for a pattern. What relationship do you notice in the simplified form column?
That's this column right here. What relationship do you notice is taking place in this column?
It's gone down by 3.
Let's say that a little more accurately. It's going down how?
It's by thirds.
By third. Okay, so we're dividing by 3 every time, right? Or multiplying by a third. I like that better than saying down by 3. So, okay, so, right, it's dividing by 3 each time. Start the activity. Okay, so we can find a pattern. Okay, so if we click there, see if I click, anyway, 3 to the 4th, and it shows, I don't know why that thing keeps popping up, it won't go away. And if I move the mouse, then the other stuff that I want to look at goes away, it's weird. Okay, so maybe can I click that one? No. Oh, I can. There we go. Okay, so 3 to the 4th, it just shows us how we got 81 out of 3 to the 4th, right? 3 to the 4th is 81. And then this one shows us how out of 3 to the 3rd, we end up getting 327. This one shows us
3 squared.
3 squared, it's 3 times 3, that's 9. This one shows us that 3 to the 1st power is 3. And if we just follow that pattern, 3 to the 4th, 3 to the 3rd, 3 squared, 3 to the 1st, 3 to the 0 power, that's kind of weird to think about a 0 exponent. But if it follows the pattern, all it's going to do is divide by 3 again, and 3 to the 0 should be 1. Does that make sense?
How?
It follows the pattern, doesn't it? But how? How indeed?
What's 3 divided by 3?
What is 3 divided by 3?
If you multiply 3 0.
Is that true? Can I get a fact check?
Can we get 3 divided by 3 is 1? That yep, checked it, it's
Because 3
true.
goes into 3 one time.
There you go.
Yeah.
So then, okay, ask your question.
But like, you can't, you're multiplying 3 0 times.
Okay, that, if you think about it that way, where we think about the number of times, here we use 3 as a factor 4 times, 1, 2, 3, 4. Here we use 3 as a factor 3 times, 3 as a factor 2 times, 3 as a factor 1 time, and then for this one, that would mean 3 as a factor 0 times. So how does that give us 1? That's a little harder to think about. I appreciate that question. I'm not really sure I have a way of answering that makes it fit with the pattern. 3 as a factor 0 times, why would that be 1? I'm not real sure about that. That's an interesting question. I don't think I've ever thought about it that way before. Let's see if we can, they're gonna give us a couple more ways to think about this, or at least one more way to think about this. Let's see what he says next.
The pattern is that each number is the previous number divided by 3, or each number is 1/3 the previous number. As the exponent decreases by 1, the product is divided by 3. We can use the pattern to find 3 to the power of 0. 3 divided by 3 equals 1. So 3 to the power of 0 is equal to 1. The card Markela needs is 1.
So this works, it fits, and it's true, 3 to the 0 power is 1. Turns out any number except for 0 to the 0 power is gonna be 1. Okay, so
0, 0, 0. 0 times 0 is 0.
there, yeah, 0 to the 0 power is still 0. 0 to any power is 0. But any other number, negatives, decimals, fractions, doesn't matter, any other number to the 0 power is 1, okay? They're gonna give us another reason why that's true here in a second.
You could also use the quotient of powers property to solve the problem. When dividing two exponential expressions with the same base, subtract the exponents. 3 to the power of 3 minus 3 is equal to 3 to the power of 0. You also can write the quotient as a fraction. Expanding each exponential expression shows that the fraction is equivalent to 1. The zero exponent property states that a to the power of 0 equals 1, assuming a does not equal 0. And we get the same answer. Markela needs to find the 1 card. Nice job, Markela.
Nice job, Markela.
Thanks,
So, so one thing that I appreciate and hate at the same time about these videos is they do a really good job of using accurate mathematical language to describe what's going on, but sometimes what he's trying to say gets lost in all of that accurate mathematical language. Okay, and so, don't need your Chromebooks out right now. So, what gets lost on us here is just this simple idea. The simple idea is this. Any number divided by itself is what?
1.
1, okay? So I'm just gonna throw some numbers up here. So if I have 4 to the 7th power, is that a number?
Yes.
And if I divide that by 4 to the 7th power, what is that?
4.
4 to 0.
4.
Any number divided by itself is,
1.
so 4 to the 7th divided by 4 to the 7th is
1.
1. Okay, so I know that has to equal 1,
Oh, okay.
right? But the rule, the quotient property that we learned yesterday tells me that when I'm dividing bases that have the same exponent, what do I do with the exponents? You subtract. So I would do 7 minus 7 is
0.
0. So that would be 4 to the 0 power,
Which is 1.
which is 1. Okay, so 4 to the 0 equals 1 because I can do, because the quotient property tells me it needs to be 1.
So like.
Right? I took away the exponents. The exponents are all gone. All right?
57, 57.
Okay, so any number divided by itself is 1. So that's why it works for negative numbers. That's why negative 4 to the 7th power divided by negative 4 to the 7th power is also 1. Because a negative divided by a negative is a positive, right? And so
Yeah.
that would be negative 4 to the 0 power, which would be a positive 1. That's kind of weird, but that's the way it works, okay? It's mathematically accurate. So any number, or, guys, any letter, x to the 0 power is 1. Assuming that x is not 0, you have to say that. You know, x will be 1 unless x was already 0 to begin with, then it stays 0, okay? Does that make sense?
Yeah.
All right, that's the rule. The new rule that we've just learned, the new property, is that a 0 exponent gives us a value of 1. Okay? All right, get rid of that. Get rid of that. Let's go here. Okay, so evaluate each power. What is negative 7 to the 0 power?
1.
Thank you. What is 43 to the 0 power?
1.
Do you see a pattern developing here? What is 1 to the 0 power?
1.
What is 0.5 to the 0 power?
1. Why is 2, 7, 0? It's 2 because 2 times 1 is 2.
There you go. 7 to the 0 power would be 1, and 2 times 1 is 2. Okay? All right, so that's a new rule. We feeling okay so far about our new rule?
Yes.
0 exponent gives us a value of 1. All right. Whoops, here we go. Let's learn a new rule.
What? Negative exponent. How?
Negative exponents now.
Simplify the expression
Yikes.
4 to the third power
She's really
divided
proud
by
of her
4
action.
to the fifth power. To begin, write the division problem as a fraction. Now use the definition of exponents to rewrite the fraction. 4 to the third power is equal to 4 times 4 times 4. And 4 to the fifth power is equal to the product of 5 fours. To simplify the fraction, remember that 4 fourths is equal to 1. The fraction is equal to 1 divided by 4 times 4, or 1/16. So, 4 to the third power divided by 4 to the fifth power is equal to 1/16.
We okay with that? Makes sense?
Yes.
All right, they showed us the expanded form, and this works. I mean, mathematically, it's perfect. There's nothing wrong with anything they did there, so I like it. This is one of those videos too where I think they do a really good job of using math language and precise wording to do it, and they stretch out this example to show us all the steps. And at the end, we're going to simplify it. We're going to look at it how it can be a little easier to look at. Okay.
A quicker way to simplify the expression is to use the quotient of powers property. The quotient of 4 to the third power and 4 to the fifth power is equal to 4 to the power of the quantity 3 minus 5, which is equal to 4 to the power of -2. The table shows some of the powers of 4. Notice that as x increases by 1, 4 to the x power increases by a factor of 4. So, 4 to the power of -2 equals 1/16.
Okay, so they've given us the next step here by showing us that when you divide bases that are the same, you subtract the exponents, right? And so the exponents are 3 and 5, and we subtract in the correct order. 3 minus 5 is -2. So 4 to the -2 power is 1/16. That's our first look at what a negative exponent does. A negative exponent does not make negative numbers. Get that into your brain right now. Negative exponents don't make negative numbers. Negative exponents make fractions. They make tiny numbers. Okay? And it kind of goes back to, remember Markela in the last video and the table that we had of her stuff? So she got down to 3 to the 0 power, and then it went down, if we divided by 3 again in her video, it would have been 1/3, and then divide by 3 again, that would be 1/9, right? So here, this one, if we read that table backwards, we're dividing by 4, divide by 4, divide by 4, and here we get to 1, and if we divide by 4 again, it's 1/4, divide by 4 again, it's 1/16. So negative exponents are a way of showing us repeated division. Okay, we're just going to divide by to make the number smaller and smaller.
Okay.
Okay, all right, let's see it.
You can use the negative exponents property to simplify expressions with negative exponents. The negative exponent property states that a to the power of negative n is equal to 1 divided by a to the nth power. In this example, the property shows that 4 to the power of negative 2 is equal to 1/16, which is 1 divided by 4 squared.
Okay, now, here's the thing. Negative exponents are they're not simplest form. We don't like negative exponents. We don't want to write answers with negative exponents in them. We always want to make sure that exponents are positive. That's the simplest way we can write an exponent. That means we don't leave a number like 4 to the negative 2 power. If it has a negative 2 as an exponent, we have to move that number to the bottom of the fraction and make the exponent positive. So 4 to the negative 2 is not a good answer. 1 over 4 squared is a good answer. Does that make sense? Okay, so all that a negative exponent will do is move a number to the bottom of the fraction and the exponent becomes positive. So we can end up with things like this. 15 to the negative 7 power. What is that going to be? What does the negative exponent do?
It goes down.
Moves it down to the bottom of the fraction. So it would be 1 over 15 to the 7th. And the exponent becomes positive. Okay? Is that all right? Okay. All right, let's see what they do next here. Okay, write each expression using positive exponents. Okay, so 8 to the negative 2 power. What do I need to do with that?
You need to put it in 1 and a fraction.
1 over 8 squared.
That's it?
That's it.
That's low IQ.
Well, it's not any more difficult than anything we've done. We just got to remember the rule. 1 over
2, 4.
2 to the 4th. This one is going to be 1 over 3 to the 5th. It really is that simple.
This is it. This is math.
Okay? Now,
How do I use this in a problem?
well, is it going to go? Okay, so this is one where, okay, don't worry about the math explanation here of what we do. We're going to simplify this a little bit. Okay, so what happens if I end up with a negative exponent and it's already on the bottom of a fraction? Well, negative exponents are not okay, right? We don't want those. We want them to be positive. So if a negative exponent on top moves it to the bottom, guess what a negative exponent on bottom does?
I go positive.
But it'll move it to the top. Okay, so if you have 1 over 7 to the negative 3, well, flip that sucker back over, and it's going to be 7 to the positive 3 power.
And then 7, 3.
7 to the 3rd. That's all it is. Okay? The explanation here makes sense of what they do, but I'm not worried about the explanation. I just want you to know the result, the final outcome. So 1 over 5 to the negative 3rd is
5 thirds.
5 to the positive 3. Okay? 5 to the positive 3. And then 1 over 2 to the negative 6th
Positive 6.
is 2 to the 6th.
Seven.
Okay? Now, hold on. We can jumble some of this stuff up too, right? I can do more than one thing at a time. What if I have this? What if I have 3 to the negative 7th over 5 to the negative 4th?
That's a good question. You add, or you divide, you add.
What does a negative exponent do on top? If a negative exponent's on top, what does it do?
Down.
Moves it to the bottom. If a negative exponent's on bottom, what does it do?
Goes up.
Moves it to the top. 5 to the 4th over
3 to the 7th. Negative.
3 to 7th.
Oh.
That's all it does. Okay? It flips them over.
What?
All right.
How does this make sense?
Well, we just learned the rule. The rule tells us what to do.
Why is that?
The rule is that if the negative exponent's on top, it moves it to the bottom, and if the negative exponent's on bottom, it moves it to the top. That's the rule.
That's it?
That's the rule. Okay.
Okay.
Now, what about this? What if I have what if I have 5 to the 4th m to the negative 2 over n to the 6th x to the negative 4th?
M for x2. Well, so if there's a positive, does it go negative? If it's on a fraction bar?
So 5 to the, let's look at one term at a time. What happens to 5 to the 4th? Does it stay or does it go?
Stays. 'Cause
Stays
it's
where it is. It's a positive exponent. 5 to the 4th. What about m?
It goes down.
It's got to go to the bottom. So I need m squared to go to the bottom. Now what about n to the 6th?
It stays.
It's a positive exponent. It's a positive exponent. It's going to stay where it is.
But m's in that spot.
N to the 6th. What about x to the negative 4th?
It goes up.
It's got to go to the top. X to the negative 4th. Oops, not negative. I botched it. Not negative 4th. Just x to the 4th. Okay? All I did was follow the rule. The rule tells me that if the exponent's negative, it goes to the bottom. If it's on top, it goes to the bottom. If it's on bottom, it goes to the top. The rule tells me that. If it's already positive, it stays where it's at. Okay? All right. So don't make it harder than it needs to be. The rule is really simple. If it's negative on top, it goes to the bottom. If it's negative on bottom, it goes to the top. If it's positive, it stays where it's at. Okay?
And this is like how numbers work out in real life. Like you can't
This is real math. So what about, finally, let's do this. We know this rule already. What if I have x to the negative 4th divided by x to the negative 3rd? What does the rule tell me about dividing numbers with exponents?
You just go that x on bottom goes up and then it just goes positive 4.
But I've got two rules. I've got the quotient rule too. What do I do with exponents?
You minus. So
You
it's
subtract.
1.
So this would be x to the negative 4th minus negative 3, which is a pain in the neck. Okay?
1.
That would be x to the negative 1.
Negative. Yeah.
So I would need to make it 1 over x.
But I thought if you're subtracting the negative, you gotta.
You
One's
add.
positive now.
Negative 4 plus 3.
It's negative 1. Yeah.
Can we get
Is
a
negative.
list of each
This is
rule?
so.
You have a list of each rule. Page 44 gives you the list of the first 4 that we learned yesterday. And what is the last page here that gives it? What is this page? What page is this?
Do you know how?
50. Page 50 gives you the last 2 rules. So you've got the list of rules, page 44 and page 50.
I hate this.
Okay?
I hate.
And look how, guys, the rule is simple. 0 exponent property. A to the 0 is 1. Any number to the 0 power is 1. The negative exponent property is a simple rule. If it has a negative exponent, it either goes from the top to the bottom or the bottom to the top. That's what it does. Simple rules. Okay? If you keep telling yourself they're confusing, they will be. If you start telling yourself they're simple, maybe they'll be that way. All right, guys, because the bell's going to ring here in a minute, and because I didn't get to the end of the lesson with second hour, we will do the assignment in class tomorrow, so no homework.
Oh my gosh, thank you. I don't like algebra.
Okay, I'm gonna get all my.
I like algebra.